Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today's class 10 subject physics, chapter number 12, as we have already finished this chapter. Topic of today's lecture, we will discuss MCQs and problems. We will try to solve 12.1 to 12.4. These pages, today's pages, we will cover 64, 65, 66, and 67. I repeat, Class 10, subject physics, chapter number 12, geometrical. The name of the chapter is Geometrical Optics. Topic of today's lecture are MCQs and problems 12.1 to 12.4. You will try to solve. Pages covered 64, 65, 66, and 67. Please open 64, page number 64 of your 10th class textbook. This is the chapter we are doing. The name of the chapter is Geometrical Optics. Today we will solve the 12.1 numerical. Numerical number 12.1. First we will do the MCQs. So before starting this numerical, I will try to give you the answers of the MCQs. The first MCQs is choose the correct answer from the given choices. The first MCQ is which of the following quantity is not changed during the refraction of light? First choice is its direction. Second choice is B choice is its speed. C choice is its frequency. And D choice is its wavelength. The right answer is C, its frequency. B, second MCQ is a converging mirror with a radius of 20 centimeter creates a real image 30 centimeter from a mirror. What is the object distance? I repeat, a converging mirror with a radius of 20 centimeter creates a real image 30 centimeter from a mirror. What is the object distance? A choice is minus 5 centimeter. B choice is minus 7.5 centimeter. C choice is minus 15 centimeter. And D choice is minus 20 centimeter. Our right answer is minus 15 centimeter. C choice is the right one. Now I'm moving towards third MCQs, which is an object. An object is placed at the center of the curvature of the convex mirror. The image produced by the mirror is located. An object is placed at the center of curvature of a concave mirror. The image produced by the mirror is located. A choice is out beyond the center of curvature. B choice is at the center of curvature. C choice is between the center of curvature and focal point. And D choice is at the focal point. My right answer is B choice. Please mark down B choice. Fourth MCQ is an object is 14 centimeter in front of a convex mirror. The image is 5.8 centimeter behind the mirror. What is the focal length of the mirror? You can find out the solution of this numerical by using 1 over f is equal to 1 over p plus 1 over q. This is the mirror formula. By using this mirror formula, you can calculate the focal length of the mirror. So the right answer is minus 9.9 centimeter, which is a C choice. So for 4 MCQs, the right choice is C, which is minus 9.9 centimeter. The index of refraction, the fifth MCQ is the index of refraction depends on which thing. A choice is the focal length, B choice is the speed of light, the C choice is image distance, and D choice is the object distance. The right answer is B choice, the speed of light. 6 MCQs is which type of image is formed by a convex lens on a screen? First choice is inverted and real. B choice is inverted and virtual. C choice is upright and real. And D choice is upright and virtual. So convex lens, so inverted and real. The A choice is the right one. For 6 MCQs, A choice is the right one. 7th MCQ is which type of image is produced by the converging lens of human eye if the views distant object. If it views distant object. A choice is I'm talking about 7 MCQs now. I'm on 7 MCQs now. A real erect same size. B real inverted diminished. C choice is virtual erect diminished. D choice is virtual inverted magnified. The B choice is the right one. The seventh MCQ's B choice is the right one. Now I am moving towards MCQs 8. Image formed by a camera is A choice is real, inverted, and diminished. B choice is virtual, upright, and diminished. C choice is virtual, upright, and magnified. And D choice is real, inverted, and magnified. My right choice is A, real, inverted, and diminished. Please mark down 8 MCQs. A choice is the right one. So real, inverted, and diminished. Ninth MCQs is now, and I'm on the ninth MCQs now. Please open 64 page and ninth MCQs I am on. If a ray of light in glass is incident on an air surface at an angle greater than critical angle, the ray will A choice is refract only, B choice is reflect only, and C choice is partially refract and partially reflect, and D choice is diffract only. My right answer is the B choice for ninth MCQ. B is the right one. Now I'm moving towards last MCQs of this chapter, which is the 10th one. The critical angle of a beam of light passing from water into air is 48.8 degrees. This means that all light rays with an angle of incidence greater than this angle will be. A choice is absorbed, B choice is totally reflected, C choice is partially reflected and partially transmitted, and D choice is totally transmitted. The right choice is B, which is totally reflected. This is the MCQs, end of the MCQs of chapter number 12. Please mark them down. Thank you. So now I'm moving towards numerical problem on page number 66. Please open page number 66 of 10th class textbook. I'm going to solve numerical problem of chapter number 12. I repeat, please open page number 66 of 10th class textbook. I'm going to tell you the numericals problem 12.1. First of all, I read the numerical statement. An object 10 centimeter in front of a convex mirror forms an image 5 centimeter behind the mirror. What is the focal length of the mirror? I repeat, an object 10 centimeter in front of a convex mirror forms an image 5 centimeter behind the mirror. What is the focal length of the mirror? As when we discussed topic of mirrors, we discussed about convex mirror and the concave mirror. I told you the convention for convex mirror and concave mirror, right? So I will use the sign convention here. The distance of the object, what is given to me, given data is distance of the object is denoted with P and the image distance is denoted with Q. You got to remember, and the focal length is denoted with small f. P, Q, and F. Distance of the object is denoted with small p, and the distance of my image is denoted with Q, and the focal length is denoted with small f. In this numerical, we are asked to find focal length, where the two things are given. The distance of the object is denoted with small p, which is 10 centimeters given to me. And the distance of the, since it is a convex mirror, so Q will be negative. Q will be negative. As I have wrote, when we discussed this topic, I told you the sign convention. Q will be negative for the convex mirror. So we will use the formula. This is called the mirror formula. 1 over F is equal to 1 over P plus 1 over Q. This is called the mirror formula, which is true for both lens or mirror. Whether it is a mirror or lens, we will use this formula. 1 over F is equal to 1 over P plus 1 over Q. You got to remember this. So since Q is minus 5, I told you is a convex mirror. So Q will be image distance will be negative. So Q will be minus 5. So just plug in the values since we want to find out focal length. So P is 10, I put 10. Q is minus 5, so I put minus 5. So if you take the LCM of 10 and 5, the LCM will be 10. And if you solve this 1 minus 2, you will get minus 1 by 10. Since we want to find out the focal length, so take the reciprocal or cross multiply on both sides, you will get focal length is minus 10 centimeters. The focal length is noted with small f, which is minus 10 centimeters, is the required answer of this numerical problem 12.1. I repeat, object 10 centimeter in front of convex mirror forms an image 5 centimeter behind mirror. What is the focal length of the mirror? This is the numerical. This was the numerical statement. Now, what is given to me? The data distance of the object is P is denoted with P, which is 10 centimeter, and the distance of image is Q, which is minus 5 centimeter. Since it's a convex mirror, so I will take the negative sign because the image distance is taken as negative for the convex mirror. To find focal length, so focal length is denoted with small f. So I will use the formula 1 over f is equal to 1 over p plus 1 over q. We will use this formula so many times. So you got to remember this. 1 over f is equal to 1 over p plus 1 over q. I just plug in the values. Value of p is 10. You know the value of p is 10. And the value of q is minus 5. 5. I put the sign minus because this is the convex mirror. So 1 over 10 minus 1 over 5, you take the LCM, then it will come minus 1 by 10. Cross multiply, taking cross multiplication, focal length will be minus 10 centimeter is the required answer. So my result will be focal length is equal to minus 10 centimeter. This is the end of the numerical 12.1. Now I'm moving towards numerical 12.2 now. This is the 12.2 numerical on page number 67 of your 10th class textbook. If you open 10th class textbook, page number 67, you will find this numerical 12.2. I am now going to tell you the discuss about the 12.2 numerical. I read the numerical statement first. An object 30 centimeter tall is located 10.5 centimeter from a concave mirror with a focal length is 16 centimeter. Where is the image located? How high is it? An object 30 centimeter tall is located 10.5 centimeter from a concave mirror with a focal length is 16 centimeter. Where is the image located? First, we need to require to find out where is the image located, and the B part is how high is it. These two things are required. Okay. So first of all, I'm going to write data. So object, you know the height of the object is given to me, which is 30 centimeters. So height of the object is noted by HO. O will be small. O will be, remember this, O will be small. It is only the subscript. So H node, object height is H node, which is 30 centimeters given to me. Distance of object P is also given to me, which is 10.5. And again, focal length is 16 centimeters. These three things are given to me. Height of the object, distance of object, and focal length. If you read the numerical 12.2, you will find that height of the object is given to me, which is 30 centimeters. Similarly, P and F, which is 10.5 and 60 centimeters, respectively given to me. Now I need to find out two things in this numerical. The part H where the image is located, which means distance of the object, which is Q, denoted with small q, is we need to find. And the height of the image is find, it is denoted with, just place I, because I didn't place I over here. You need to place I, small I, underneath the H, where my cursor is pointing out. I is the image height of the image. Please place HI over here. I mean image. Distance of image Q, I want to find out, and height of the image HI is I need to find out. Since I know the formula, I told you I will use this formula so many times. 1 over F is equal to 1 over P plus 1 over Q. This formula is true for both lens and mirror. Whether you are discussing about mirror or whether you are doing lenses, you can find P, F, and Q with the help of this formula. If two things are required, if two things are given to me, then I can find out the third thing. So this important, this formula is important. 1 over F is equal to 1 over P plus 1 over Q. This is called mirror formula. Since I want to find out Q, so what did I do? I multiply both sides by PQF. I multiplied here, and I multiplied here with PQF just to separate out Q. So I multiply, when I multiply here, PQF will be on the top and F will be at the down. In this case, I multiply PQF will be on the top and P will be at the down, and PQF on the top and Q will be at the down. So F will be cancelled with this F, P with this cancel will be with this P, and Q will be cancelled with this Q. So what will be left? PQ, QF, and PF. In the next continued. This 12.2 numerical is continued. So in the next, you will see PQ equals to QF plus PF. Look, PQ is equal to QF plus PF. Now take this one, this one on the other side. So plus PF, if plus QF, take this one on the other side. Plus QF, if is go on the other side of the equation, it will be negative. So PQ minus QF equals to PF. So take the F, PQ common from these two. So what will be left? P minus F and PF on this side. So you need to find out the Q. So here P minus F is multiplied. If it is go down, it will be divided. So PF divided by P minus F. So just put in the values. P is given to me 10.5, as I have already told you. P is given to me 10.5 and F is given to me 16. P is given to me 10.5, F is 16. So here P is again 10.5 minus sign over here, and the 16 minus 16. If you 10.5 multiply by 16, you will get 168, and 10.5 minus 16, you will get minus, sorry, here minus 5.5 will come. So if you divide 168 divided by 5.5, so the Q will be minus 30.54. Q will be minus 30.54. Q will be minus 30.54, where negative sign indicates image is virtual and correct. This negative sign will indicate, since there is a sign Q is negative, so the negative sign indicates the image is virtual and correct. This is the first thing we are required. This is the first thing we are required. Q we have already found. So Q is negative minus 30.54. So you know this is the concave mirror. In concave mirror, Q is taken as positive. So you won't see negative sign with the in the answer. So please make sure this is the concave mirror. So negative sign will be ignored. So Q will be, my Q will be minus 30.4, only plus 30.4. Negative sign indicate this is the image will be virtual and erect. Now the second thing I want to find out is height of the image. How high is it? How high is it? So this is the formula for magnification. The magnification formula is M is equal to Q by P. Since I have found Q, Q is 30.4. I have ignored negative sign because this is the concave mirror. So that's why I have put plus 30.54. So P is 10.45. You can see over here. P is 10.5, right? And Q I just found, which is 30.4. Just plug in, you will get magnification M is equal to 2.90. Then I use the formula again. The magnification is HI over H naught, and magnification is Q by P as well. Magnification is Q by P as well, and magnification is M is equal to HI over H naught. Since we want to find out the HI, as I have already told you that we are required HI. You can put over here HI. So height of the image we are required. So I will use this formula. M is equal to HI over H naught. Just cross multiply. So M multiplied by H naught. Just put in the values. And height of the object is 30 centimeters. This is given to you. And you just find the M magnification, which is 2.90. If you multiply 2.90 with 30, you can get 87.27 centimeters. It is the height of the image, which we need to find out. So Q, image distance is Q is 30.54 centimeter and HI is 87.2 centimeter is the required answer. So this is the end of the numerical 12.2. Now I'm moving towards numerical 12.3. I read the numerical statement first. An object 12.3 on page number 67. Please open page number 67 of 10th class textbook and page number 67, numerical 12.3 I am on. Given data, object distance, I read the numerical statement first. Of an object and its image is concave mirror are the same height, yet inverted. When the object is 20 centimeters from the mirror, what is the focal length of the mirror? In this numerical, we need to find out focal length, f, small f, right? Object distance and image distance are same height, which is 20 centimeters given to me. So P will be 20 centimeters because they have same height. Object and image distance are of same height. So P is 20 centimeters, then Q will be 20 centimeters because they are of same height. And focal length is required. So I will use the same formula as I discussed in my previous numerical 12.1 and 12.2. So I will use the same formula here as well. 1 over F is equal to 1 over P plus 1 over Q, which is called the mirror formula. Again, I need to find out the F. So I multiply both sides PQF. Here I multiply PQF. Here I multiply PQF. Here I multiply PQF. So F will be cancelled with this F. This P will be cancelled with this P. This Q will be cancelled with this PQ. What is left? PQ. Here PQ left. Here QF left. Here PF left. Then separate out F, taking common from these two. F is taken as common, Q plus P. So since I want to find out F, so Q plus P is multiply here. If it is go on the other side of the equation, it will be divided. So F will be PQ divided by Q plus P. Just put in the values. P is 20, Q is 20, P is 20, Q is 20, Q is again 20, P is 20, 20 plus 20, you can get 20 multiplied by 20 is 400, 20 plus 20 is 40. If you divide 400 by 40, you can get 10 centimeter, which is focal length. I have found the focal length in this numerical. Focal length 10 centimeter in this numerical. Focal length is required. I repeat, an object and image is concave mirrors. I told you in concave mirror where the Q will be positive. Q will be positive and focal length will be positive. But convex mirror, the focal length and Q will be negative. Since it is a concave mirror, that's why Q is taken as positive and focal length is always come as positive. So object distance P is 20 centimeters. Image distance Q is 20 centimeters because they are of same height. That's why P and Q will be same. If P is 20 centimeters, the Q will be 20 centimeters. In this numerical, we are required to find out focal length, and focal length is noted with small f. I use a formula which is called the mirror formula. 1 over f is equal to 1 over p plus 1 over q, multiplying both sides with pqf. Here pqf multiply. Here I multiply pqf. Here multiply pqf. This f will be cancelled with this f. This p will be cancelled with this p. This q will be cancelled with this q. What is left then? PQ is equal to QF plus PF. So if you take common from F on both these two expression, so F will be Q plus P. So if separate out F, so Q plus P is multiply here. If it is go on the other side of the equation, right? Just plug in the values. P value is 20, Q value is 20, Q is 20 plus 20. If you solve this, you will get focal length is 10 centimeters. The focal result will be focal length f is 10 centimeters. This is the end of the numerical 12.3. Now I am moving numerical 12.4, which is the last numerical of today's lecture. 12.4. Find the focal length of the mirror that forms an image 5.6 centimeter behind the mirror of an object placed at 34.4 centimeter in front of a mirror. Is the mirror concave or convex? He is asking us what type of image is. What type of mirror is? Is it the concave mirror or convex mirror? So find the in this numerical he is asked to find focal length, right, and the mirror type. So what is given to me? This is the distance of image is distance of image distance is q, which is 5.66, and distance of object is 34.4 centimeters. Focal length is f. We need to find out, and the mirror type is this. So 1 over f is equal to 1 over p plus 1 over q. So I again multiply, as I multiply in my last two numericals, I again multiply PQF on both sides. So if you multiply PQF and solve this, you will get Q, since Q is negative. So this F will be cancelled with this F. This P will be cancelled with what is left? QF minus PF in PQ. Take F common from these two, Q minus P. So F is PQ divided by Q. Since F is Q minus P is multiplied, if it is go on the other side, it will be divided. So PQ divided by Q minus P. Just put in the values. P is 34. P is 34.4 and Q is 5.6. Just put in the values. The P is 34.4 and Q is 5.66. Just Q is 5.66 minus P is 34.4. P is 34.4. So if you subtract this, you will get minus 28.674. If you divide 194.704 divided by minus 28.74, you will get minus 6.77. Since focal length is negative, so since my focal length has come negative, so the mirror will be convex mirror. Negative sign indicates mirror is convex. Since my focal length comes to be negative, so my mirror will be convex mirror, because in convex mirror our focal length is negative and Q will be negative. I repeat this numerical. 12.4. Find the focal length of the mirror that forms an image 5.6 behind the mirror of an object placed at 34.4. In front of the mirror, is the mirror concave or convex? You are thinking that why sir has put distance of image, why sir has put minus sign over there? Because he in the statement, if you read the statement carefully, behind the mirror, the image 5.6 centimeter is behind the mirror. Whenever you find that behind the mirror, the Q is taken as negative. That's why I taken as Q as negative. So Q will be negative. I use the formula 1 over F is equal to 1 over P plus 1 over Q, multiplying both sides, PQF, PQF here, PQF here, PQF here. F will be cancelled with this F. This P will be cancelled with this P. This Q will be cancelled with this Q. So what will be left? I'll do it again. F will be cancelled with this. This P will be cancelled with this. This Q will be cancelled. What is left? PQ equals to QF minus PF. If you take F common, so what will be left? Q minus P. So here Q minus P multiply. If it is go on the other side of the equation, it will be divided. So PQ divided by Q minus P. Just put in the values. P is 34.4. As I have already told you, value P is 34.4 and Q is 5.66. Q is 5.66. So here 5.66, Q is 5.66 minus QP is 34.4. So if you solve this, multiply this, you will get 194.704. And if you subtract this, you will get minus 28.74. Our focal length comes with negative sign, minus 6.66 centimeters, 6.77 centimeters. F is minus 6.77 centimeters. So negative sign indicates when the focal length is negative, it means it is a convex mirror. Mirror is convex. In this numerical, we are asked to find focal length, which I found minus 6.77 centimeters, and this negative sign says that this is the convex mirror, as we discussed the sign convention when we started the chapter. or we discussed about the mirror, convex mirror, concave mirror. I told you, convex mirror, F will be negative, Q will be negative. Concave mirror, F will be positive, Q will be positive. Since F is, so negative sign comes with the focal length minus F, my F is equal to minus 6.77 centimeter. So my, this is the convex mirror. So this is the end of the numericals, today's numericals lectures, numerical 12.4. We discussed 12.1, 12.2, 12.3, and 12.4 MCQs. So your homework is practice the numericals and write once on a read register. So students, if you have any questions regarding today's topic, if you didn't understand anything or in today's lecture, please feel free to ask questions. Thank you. Please, if you have any question, Harun, if you have any problem or in today's lecture, please feel free to ask questions. Thank you.